Good afternoon and welcome to the Embedded Executive Podcast. My name is Rich Nass. I am with Open Systems Media, more specifically with embedded computing design. My guest this week is Digi Vice President Mike Rohrmoser. How you doing, Mike?
I'm doing very well, Rich. How are you doing?
I'm doing just fine. The reason I want to talk to you, and I'm not sure if you're going to want to talk to me when we're done here, but something crossed my desk that it was attributed to somebody at Digi. I won't say it's you, but since you're representing the company, I have to say that it's you in this instance that said IoT deployments are slowing because embedded devices aren't able to talk to each other. Um, is this something that you're actually seeing? Because I am not seeing this.
Yeah, I think that the context for the statement is probably important. I would say most important. So I think there's certainly, which you are very aware of as well, I would say is like IoT in itself can be very complex. And then, if you specifically look at an IoT solution with that has multiple components on the hardware and software side, it's certainly that complexity that goes all the way from the hardware to the software to maybe the cloud-related aspect of it, when you want to manage something at scale or get data at scale, then I think that is certainly then it can be a true statement. But I think it's a more nuanced view, I would say, context-wise. So for me, that's, a lot of it is related to the specific aspect of it. IP is certainly one way, obviously, as a foundational transport, how those devices and how IoT devices can also talk to each other. Obviously, there's other protocols that are leveraging IP in general. But that is also, I think, where the conversation that we are having comes into play, where we're talking about, well, how does mesh networking, for example, play into all of this? How can a mesh network, for example, that's IP based, how can that help actually to take away some of that complexity, while also building something that is future proof and secure, most importantly, over time.
So let's make sure we're doing an apples to apples discussion here.
Hmm.
Are we referring to the factory floor, for example? Because when
Hmm.
you talk about IoT, you could be talking about almost anything.
That is correct. Yes, of course. It's a very broad
Okay.
field.
Okay. So if we're looking at the factory floor, there are many different things that are being introduced that could potentially make these things not communicate. A is just bad
Hmm.
design. B is
Hmm.
artificial intelligence, and
Hmm.
C is security not implemented correctly. Are you
Yep.
seeing all of these same things? And if so, what do we do about them?
Well, there's certainly components, all of them play into it. I think again, context is important depending on the use case and specifically what we're talking about for applications and industries. But yeah, all of them certainly play into that. So security is, if I go backwards, security is a very important aspect. Specifically, what kind of protocol are you using? Again, IP can be, very useful for that kind of setup because then you have an existing infrastructure, whether it's, for example, TLS that you're using on the IP side, can you actually extend that security story that can grow also and last over time and scale also, not just from a number of devices perspective, but also in the future, when we're talking about PQC, post-quantum cryptography, how can IoT networks, and I'm defining them now as the networks being between the edge and the actual, well, maybe the near edge and the far edge, if you remember those, so actually the end device, the node, how can we keep those secure also over time, specifically also when we talk about wireless technology with respect to IoT. And that is certainly then also where I would say technologies like Wi-SUN come into play. Wi-SUN actually is open standards based. It uses X509 certificates, for example, for authentication and device identification. It uses TLS, already uses 256-bit AES encryption, which is, at least for now, is considered PQC safe. But it also is, given that it's based on TLS in general, it uses a framework that can be extended, right? So there's already RFCs underway that look at, when we talk about PQC again, how to leverage hybrid PQC, for example. And so you have actually an existing framework for an IoT device and the connectivity that comes with it that is IP based, it's open standard space, which is very important in my opinion, that can then also extend and, support the long life cycles that you typically see in industrial applications and for embedded devices in many cases that can be 10, 15, 20 years, so.
Okay, there are two different things that I want to address there. One is you brought up YSUN.
Mhm.
While it's a great protocol, now we're talking different languages in our environment. Is that part of the issue that we are talking different languages on the floor?
I think that's certainly part of it. I think it's when we talk about so there's the wireless connectivity itself, right? So whether
Yeah,
you're
I'm
using
I'm doing Bluetooth here, I'm doing Wi-Fi there, I'm doing Wi-Fi for everything else.
exactly, yeah. So I think, and also then again, it depends on the use cases, right? For some use cases, some of those technologies that you mentioned are more appropriate than others. For example, let's talk about battery powered devices versus mains powered devices. So yes, that's certainly part of it. So I think the more you can, let's say, standardize or minimize the number of, let's say, when we talk about wireless specifically, you can standardize on specific protocols that are being used and are interoperable also. So all of the ones that you mentioned are interoperable. Now, yes, it's a mix. It's Wi-Fi, it's Bluetooth, it's Wi-Fi, but they're interoperable. They're all based on open standards. So I think that in itself is certainly a very good approach from a design perspective. You mentioned, design in general. Also from a network design, from a solution design perspective, picking those protocols that are interoperable and open will certainly help a lot or can help a lot to make them scale and reliable, and then also, easier to integrate. And then especially if you look at Wi-Fi and Wi-SUN, then also if you look at the transport side of things, you actually have something that's IP based, right? So now you have an infrastructure that you can use where the nodes itself, the end nodes, the actual IoT device, whether it's better operated or not, can also be IP enabled, which can make the whole management and again the future proofing of the solution much easier over time as well.
Okay. Now the other issue that you brought up was the longevity of some of these systems. It's not unusual to see a system out there in the field for 15, 20, 25 years or longer.
Correct.
Um, and they may have been based on some standard that doesn't exist today or isn't
Mhm.
adhered to today. How do we ensure backward compatibility to something that's just old?
Yeah. Well, again, I think I would actually say the same thing from a theme perspective. The more I would say you build based on open standards, I think the better it is, the higher the chances are that your system actually can grow over time as well with changing requirements. We all know that. So when you look at proprietary standards, yes, they often, in many cases, are very tailored to specific use cases, but they come also with a certain technical debt over time, I would say. And again, talking about YSUN, if you have something that actually is an open standards that actually is maintained by an official body of some sort, whether it's an industry body or actual regulatory body, but in this case, more an industry body like the YSUN Alliance, then you actually know that actually the standard is maintained, making sure that the foundation of the standard actually is based on standards, open standards. Like I said with YSUN, it's 802.15.4G on the wireless side. It's TLS, it's X509 from a certificate perspective. So you actually have something as a foundation that is maintained as a standard, but then also has a technical foundation to actually grow with changing requirements over time. So that at least, in my opinion, does improve the chances to actually have something that is more still relevant and viable and working in, let's say, 10, 15 years down the road, which can be challenging with proprietary solutions, right? Especially also, you brought up the backwards compatibility piece. Standards like Wi-Fi or Wi-Fi for that matter, they have backwards compatibility. Yes, even there, I would say, when you look at Wi-Fi over time, I think it's backwards compatibility that's not maybe most ideal with devices that are, let's say, 10 or 15 years old on the Wi-Fi side, but they still work together, right? So I think that's a very important aspect of building it is, I think, is the open standards approach across the board.
Okay. And where does Digi fit in all this?
Well, obviously, so from a from a connectivity perspective, we do support a lot of open standards as well. When you look at our RF modules, the DGXP modules, whether it's Zigbee 8 or 15.04, we support Bluetooth, of course, Wi-Fi, but we also recently then have introduced a Wi-SUN solution. And Wi-SUN, again, if people are not familiar with that, actually is a leading IPv6-based sub-gigahertz mesh networking technology that has been deployed with over 100 million devices already. Comes originally out of the utility space. Funny fact is the name currently is the new name is Wireless Smart Ubiquitous Network. It used to be Wireless Smart Utility Network, so that's a nice branding effort there. But the whole idea with the ubiquitous, of course, is that, well, yes, it comes out of the utility space, but it's capable to do much more than just utility. But having said that, the fact that it actually its origins are from the utility side, and with 100 million devices, you already have proven scale. It's it's an established standards. I think nobody would challenge that utilities in general are very sensitive when it comes to security and longevity as well. Smart meter deployments typically, if you look at the TEPCO deployment in Japan, there's 29 million devices. There's millions of devices in the US as well. So it's inherently built to have longevity, to last over time, also to be backwards compatible, to your point, right? So the technology itself is proven and can be easily then also transferred to other use cases outside of utilities. So what we provide then as part of that Wi-SUN offering that is about to come out is the XP Wi-SUN modules. So different module types, some for battery operated devices, some for mains powered devices. We will have a border router, which is essentially a gateway that is used to connect the nodes in that self-healing mesh network to the backend, so the border router itself. But we also support, edge compute, for example, and can also deploy AI/ML on the edge through the border router itself. And then also the backend support with respect to device management at scale, fleet management at scale. Also, what else can be provided to make it easier for customers? Because when we talk about security, we're talking about certificates. Obviously, in order to use certificates properly, you also have to maintain them. You have a PKI lifecycle management. So, but if you want to revoke certificates, you want to roll certificates, you want to update them. So all of that actually is something that we will then also provide as part of that fleet management that Digi Remote Manager provides by extending it beyond the device fleet management, like firmware updates, which is very crucial, of course, on the node as well as in the gateway, but also adding value with respect to network management, PKA lifecycle management, so that you actually have one single pane of glass that actually can maintain and manage all of those devices in that distributed network that you have based on Wi-SUN. And Wi-SUN itself is IPv6 based. So we also then provide on the border router side IPv4 to IPv6 translation, because not everybody is using IPv6, as you know, even though we talked 10 years about IPv4, address space running out. So we are helping customers that don't have an IPv6 infrastructure as well by doing that network translation for them, but still have a essentially future-proof system in place, because if in, let's say, 10, 15 years, things are really moving to IPv6, you already are ready to do that, based on the Wi-SUN infrastructure.
Very good. So I think we've answered the question.
Well, I hope so.
So, and if we follow the standards, we won't have this problem. So everybody will be able to talk to everybody nicely, right?
Absolutely. Open
Very good.
standards. Open is good.
Open is good. Thanks, Mike. I appreciate your time.
Okay, thank you, Rich.
That was Mike Rohrmoser. He is a vice president with Digi, and I am Rich Nass with Embedded Computing Design.